something you'd like to check again? The scientist always goes back to his experiment and does it again. He wants to check to be sure he's gotten the essence of what was said. So, this then is a description that Pat has developed to catch the essence of what that statement says. You have 5 balls, you pull out one from one end, you let it go. It hits the one that's nearest, causing the one at the opposite side to fly away in the manner of the first. If you'd like, you can also state the fact that this thing goes back to square 2, it repeats itself, but in the opposite direction. Okay? This is a perfectly valid and a good language to describe, but let's see how useful it is to describe what we see. If you don't mind, Pat, I want to make its modification, make it even shorter. This, for example, catches the fact that the balls were at rest initially, and that doesn't really tell us anything. So let's go along with erasing that, just to shorten the notation, to catch the essence of the experiment. The fact that this is being pulled away, I think, kind of is caught here in the sense that that this ball is falling into the other 4. So do you think we need to have both these?
Well, the statement says pull away, so I just
You're
thought
perfectly right. You're perfectly right. Okay, so we have those 3. Let me now, in terms of your language, ask you a question. Okay? And the question I want to ask you then is this question. Oops. You have them touching, and that's important. So I don't want to... That's statement 1. Statement 2. So, 1, 2, question mark 3. Glenda, do you understand what we're asking? I've asked you a pictorial question. I have a possible situation in which I'm asking a question. Can you now tell me can you hypothesize for me on the basis of what you induce from the other experiment, what the answer to that is in terms of the pictures? Okay. You need some arrows, I think, to indicate, just to make it complete using what Pat has said. Arrows mean something. Okay, there's an answer. Ron, agree with that? Maine, we all agree with that, right? Whether we agree with it or not doesn't really matter. The important thing is whether or not that's what happens. All right, can we ask our chief experimentalist then to test it out?
That's okay.
That's indeed what happens. Okay? Well, who's right?
One is right. Like you pull 2 on one side.
No.
Okay, this is complicated. Now you keep looking.
It's alternating.
You think that when they have 3 on the right, then they all will move to the left. All right, so we have 2 possibilities. That's Ron's answer. Vic?
I think I favor those.
You favor Maines?
Yeah.
Pat favors Maines?
No, I think I favor Ron.
You favor Ron? Glenda?
I think I have a number 3.
All right, number 3. What is it?
That there'll be 1 ball left on the other side.
That there's 1 ball left on the other side. No.
Let me see.
That there's 1 ball left on the other side. I think by that I should draw 4 balls coming up, then, and 1 ball left in the center. There are many reasons underlying why each person has selected what he has done. And we needn't go into those yet. The proof of the pudding, right? All right, Vic, you want to assist and perhaps... Now the experiment says we have 3 coming up.
Right.
Which solution?
Wait, let me do it again. Let me do it
Do it again.
The third one is right.
Okay. Bronze seems to be right. Okay? So, bronze is the right solution. That's experiment number 3. We can also perform experiment number 4. And what might that be? And what would be the result of that?
One standing still, one going.
Now you're able to, now you're beginning to induce what the answer must be. You said, I observe that, I kind of feel that, but something happened here all of a sudden. And if I can anticipate Mame a little bit, it was having more on one side than the other. That led her to say, and this is fine, that something different must happen now. And this is the way scientists do use their intuition. This is what it's all about. But she induced not quite the right answer in Ron. So can we generalize here then? Because after, and this is what I asked you about patterns. And patterns of behavior means a generalization. Okay? Well, now we have lots of pieces of information. You want to reach inside that and pull out the essence, the generalization of what's said. So, there's no reason why we can't do a Mame, Pat, Glenda, Ron, Vic, conservation law. Now, you understand now its pattern of behavior by scientifically doing experiments, looking for patterns, and then generalizing.
One fellow said, fold this sheet of paper, you know. I said, okay, you tell me, I'll follow your instruction and do exactly what you say. And he said, take the left side and fold it over to the right side. So I did that.
Wow.
And then I creased it, and Brantley said, he didn't say crease it. I said, yeah, but the computer has something stored in it already, you know.
No, that's it. That's exactly what it's all about. Yeah.
The real good thing about this, you want the kids to think logically, and you want them to really cut down and reduce their errors to a minimum. And unless they reduce their errors completely on this machine, it doesn't work.
That's right. Or make explicit what they are. I notice many students, the common error is that they sort of assume, like the folding of paper. It's a perfect model for that. They assume that when you say do this and do that, that you're supposed to put this under here and divide by 2, but they don't say it. And unless you make it explicit, you know, you just can't function.